We have now started learning about rocks. You've learned about igneous rocks, you have learned about metamorphic rocks, and now we're going to start learning about my favorite, which are sedimentary rocks. And the reason that they're my favorite is because they can tell us so much about the environment that they were created in. They are, to me, they're like the words in the history book, right? They preserve that information much better than the other types of rocks do. All right, so in order to talk about sedimentary rocks, first we have to figure out where they come from, what they're made out of. Up until this point, we have talked a lot about how rocks are formed, right? The material that goes into forming them. But there also has to be some sort of mechanism that breaks those rocks down, because if we continue to make more and more and more and more and more rocks, we'd eventually run out of material. So first we're going to talk about weathering and soils so that we can talk about those materials that make up sedimentary rocks. So on to weathering. So weathering is just the process of breaking a rock apart, wearing it down, starting with one big piece and tearing it apart, weathering it apart into multiple little pieces. And there are two types of weathering that we're going to talk about. The first is physical. This means the mechanical process of breaking down a rock. The chemical composition of the rock doesn't change. The only thing that changes is its size and shape. It's just broken up into bits. The second type of weathering is chemical weathering, and this weathering does actually change the chemical composition of the rock, right? There's chemical processes, breaking bonds, creating bonds with the elements inside the rock, and actually changing the rock's composition. Let's focus on physical weathering, right? Again, this is just fragmenting by physical processes. There's no chemical change in the rock. The rock stays the same other than its size and shape. It's broken down. So physical weathering acts on the surface area of a rock, right? The more surface area that is exposed to the atmosphere, the elements, the more that rock will physically weather. And what's cool is that the more you break down a rock, the more surface area it has, right? So the more a rock is physically weathered, the faster it will weather. Now, there are several mechanisms for physical weathering, and we are going to go through all of them fairly quickly, just because I want to show you the variety of physical weathering processes. So the first one is pressure release. So we know that rocks are formed often deep, deep, deep inside of Earth. And that means they're under intense pressure when they're formed. But then they can be uplifted to the surface, exposed on the surface. And when that pressure is released, those rocks can start to expand. It's kind of like they're breathing after so long of being under pressure. And that expansion can cause them to start cracking. And those cracks we call joints. So sheeted joints, they're pretty cool. Sheeted joints happen on horizontal flat slabs. So a rock that has sheeted joints will have several parallel cracks in it. And those parallel cracks, as I said, the more surface area that's exposed, the faster that rock is going to weather. So cracks create more surface area. Those cracks erode and erode and erode and erode and erode until eventually you get these really gorgeous linear arches, right? So if you've ever heard of Arches National Park in Utah, it's gorgeous. I hope you all get the chance to go out there at some point. This is all created because of pressure release, creating joints that weather to eventually form these beautiful linear arch features. All right, the second mechanism is abrasion, right? And this is just when particles collide, right? You can imagine one rock hitting another rock. There's a lot of force there and they shatter, right? That's abrasion. This is really common anytime there's movement, right? So wind, water, ice, as it's moving particles, it's going to start abrading, wearing those particles down. So this almost art sculpture looking rock was actually created just by snow and wind abrading that rock and creating those lovely features. The third mechanism is freeze-thaw. So rocks naturally have lots of cracks in them, and water can flow down into those cracks. And if it gets really, really cold and that water freezes, ice takes up a larger volume than water because that water has to expand as it turns into solid ice. Right? So as that water freezes to ice, it's going to expand and it's going to put pressure on those cracks and force those cracks out further and further and further. And then maybe the temperature warms up and that ice turns back to water. And then it happens again, and those cracks get bigger and bigger and bigger. And then the ice turns back to water. And over and over and over, this freeze thaw makes bigger and bigger and bigger cracks that eventually fracture and wear down the rock. Right, hydraulic action. Water is very persistent and very erosive. So anytime you have the movement of water like waves, streams, rivers, rain, that hydraulic action, that continual beating of that water on the rock is going to erode that rock. And I think hydraulic action is one of the most effective forms of physical weathering. So for example, the Grand Canyon, the entire Grand Canyon was eroded mostly by water, right? Just by the Colorado River eroding down into that canyon, creating that canyon. So hydraulic action is very powerful. The last two we're going to talk about, I just enjoy these. They're both due to biological processes. This first one is root wedging, right? So vegetation, plants, trees, when they're tiny, they've got tiny little roots. So their tiny little roots can grow down into tiny little cracks in rocks. But as the tree grows, the root will also grow. And as that root grows bigger and bigger and bigger, it's going to break apart that rock. So as trees grow, they're actually more powerful than the rocks, and they can break open rocks. And then finally, animal action, right? Anytime an animal digs in the ground, and we are animals, so anytime we dig in the ground, that's animal action, that's physical weathering, breaking apart those rocks.